So let's see for ourselves. So this is another scenario where this is something we've been working on a long time. And it's a really common thread. It's usually the first thing that people think of when they decide, hey, I want to go use a quantum computer. It's route optimization. And for us, route optimization is interesting because it is very well researched. It's very well understood, and from manufacturing all the way to delivery to a shelf. So we recently took another crack at this problem for vehicle route optimization, and we got even further than we were before. So 100 packages, 3 stores, and 10 trucks. And the nuance here is we switched the formulation so that trucks could make multiple stops at the depot rather than being set for one schedule for the day. And by doing this, we actually added more opportunity for, in this case, the quantum annealers. It was a better fit problem with a little bit less constraints that fit the architecture of the hardware more efficiently. And so we were able to run it at a little bit of a larger scale. And so it's just by trying these things over time in different ways on different hardware and changing your formulation, you can make small steps forward in what you can do. I can show you this demo real quick. Yep. Okay. So I'm going to skip through this. We kind of talked about what this is, but it's solving a mixed integer program and mixed integer problem. You can see here, I can create a scenario, select different depots, select number of trucks, select different delivery options, and then use this tool to generate routes. And so this is going to go query our system and look for, and you can see here for the different numbers of vehicles selected, it planned out the routes throughout the day. It estimated the times it would take to get to the different pickups and deliveries. You can even see, so this is the detail for vehicle 1. You can even see more nuanced information like what the what the costs are for the entire system. So 88 stops in total. This is the mileage, the duration it would take, and the cost per mile and the labor cost for in order to run this route delivery system in this region. And so this is a long way from, 3 trucks going on 9 locations to now we actually have costs and estimates. We're building in workforce estimates and durations, labor costs and delivery cost, and mileage as well. So you can see just in the past few years how more mature some of the hardware is and more capable it is of running this, as well as we've made more investments in the algorithms, the types of results or examples we can get. So right now, this is not quite as good as the classical system. It's comparable, and for a problem size, this is engineered for this size of problem. If the problem size increases dramatically more than this, then it wouldn't be able to run on the quantum system. And classical systems can solve this problem with more precision and more accuracy today. So what we can get within reasonable, comparable solutions is where we're at right now. Something that can take in more variables and more constraints, that's faster at processing those and can give you a more efficient result. And even if it's just, if you think of a global supply chain, even if it's just 1% better, they can be billions of dollars. So what's the value of the global parcel delivery business? 500 billion. Right, and so this is global parcel delivery. It's not all global, shipping, right? Which would be a larger number.